rational numbers. What are rational numbers? Well, hopefully you can tell from its name that the word has ratio in it. So rational numbers are any number that you can write as a ratio or as a fraction. So the whole number 2 is a rational number because that's the same thing as the fraction 2 over 1. Negative 3 is a rational number because that can be negative 3 over 1. Obviously, all the fractions that you've studied before are also rational numbers, like 1/2, 3/4, negative 7/8. These are all rational numbers. Even decimals can be rational numbers because you know that a quarter can be written both as 25 hundredths and 1/4. So these are all rational numbers. So now you're thinking, well, why is this a big deal? Why do we got to give it a name? What we're doing is exposing you to the larger family of numbers. So you started off in elementary school working with your whole numbers, 0, 1, 2, and so on. So that's the family that you started with. Then in 6th grade, 7th grade, you expand that knowledge and you realize that there are negative numbers, which you see on thermometers and all sorts of things like that. So in addition to the whole numbers 0, 1, 2, 3, and whatever, you also have the opposite of those positive numbers. So you got -1, -2, -3, and so on. And we called those integers. And so we've expanded that family. Integers are those negatives plus all of those whole numbers. And now with rational numbers, we've expanded the family even further with half, -3.2, and so on. And eventually you're going to find out that there are more numbers outside here called irrational numbers. Now, some decimals are rational, but not all of them are rational. Obviously, the easy decimals are rational, like half, because that is the same thing as 5 out of 10, or a half. Also, 0 and 3/100ths. That's going to be rational because we can rewrite it as this fraction. And what you notice about all of these is that they end. The decimal doesn't keep on going forever, and these are called terminating decimals because they end. And terminating decimals are easy to change into fractions because all you need to know is the place value. You got to remember that this is the tenths place, hundredths place. If there was another one, that would be thousandths, then 10,000ths, and so on. There's another kind of decimal that is rational, and that is the repeating decimal. So a repeating decimal would be something like 1/3, which is the decimal 0.3333 forever. And a shortcut way of writing that is to put 0.3 and put a little repeating bar over the 3, and everyone understands that that means the 3 goes on forever. Another one would be 0.2525. You see the pattern? You could rewrite that one as just 0.25 repeating. So these repeating decimals are rational as well. All right, so let's practice changing a rational number, this decimal, -10 and 24/100ths, to a fraction. Obviously, this part's easy, -10, and then we got a fraction of 24, that's going to be the numerator, and then you look at the place value of the last digit, and it goes hundredths because it goes tenths, hundredths, so we got -10 and 24/100ths, or when you simplify it, you get -10 and 6/25ths. We can also write all rational numbers as decimals. So some decimals are rational numbers, but all rational numbers can be written as decimals. Let's start with an easy one of -3 and 7/8. Obviously, our decimal is going to be negative 3 point something. And to change this fraction into a decimal, you use division, because the fraction bar also means division. And it's always going to be the numerator divided by the denominator. So we got 7 divided by 8. And obviously 8 doesn't go into 7, so we put 7.000. We put a bunch of zeros because 7.0 is the same as 7 whole. Then you do your division. So 8 goes into 7 0 times. Decimal comes straight up. 8 goes into 70 8 times. 8 times 8 is 64. Bring down the 0. 8 goes into 60 7 times. And then 8 goes into 45 times. So we have the decimal 7/8 is equal to 875 thousandths. And so then we just take that decimal and put it here. So negative 3 7/8 is equal to negative 3 875 thousandths. Write this rational number as a decimal, negative 7/11ths. So again, we do the same thing. We remember that the fraction bar means division, and it's numerator divided by the denominator. So we've got 7 divided by 11. Again, the 11 can't go into 7, so we put a bunch of zeros. It's still 7. And then we say, can 11 go into 7? No. Can 11 go into 70? Yes, 6 times. The remainder of 4. Bring that down. Can 11 go into 40? Yes, 3 times. Can 11 go into 70? Again, 6 times. Put another 0 since we had a remainder. Bring that down. And maybe you're noticing that 11 goes into 40. That's 3 times. We have a repeating decimal. The 63 is repeating. So negative 7/11ths is the same as negative 0.63 repeating. Just in case you were wondering, negative 7/11ths can also be written as negative 7/11. See how I put the negative in front of the numerator here, but put the negative in front of the whole fraction here? Those two things are exactly the same. You can even write it like this, 7 over negative 11. Those all three are the same, but I would say that the two most common ways of writing it are these two. They're all three the same. Now, ordering rational numbers is a lot like when you just were putting fractions in order in earlier grades. The key is to make all the numbers the same so that they're easier to put into order. So that might mean making all the numbers into decimals. Or if you want, you could make them all into fractions with the same denominators, whichever way you think is the easiest. Let's put these into order. To be able to do that, let's first change them all into decimals. Negative 3/4, that's negative 3/4 we should memorize already is 75 hundredths, because that's like money. 3/4 is the same as 75 cents. This one's already a decimal. This one's already a decimal. Here we've got 1/3. We want to change that to a decimal. If you don't have it memorized, you can divide. So you got to go 3 goes into 1. One-third is actually 0.3 repeating. All right, now we got negative 5/3, which is going to be a mixed number, but you don't have to change it to a mixed number right away. When we do the division, it'll change it into the correct decimal. We're going to have 5 divided by 3. That negative 5/3 is going to be negative 1.6 repeating. Now let's put them all into order now that they're all decimals. The negative numbers are obviously the smallest, so let's put those from least to greatest. We've got negative 5/3, which is the same as negative 1.6 repeating. That's the smallest. Then the next one is negative 75 hundredths. Now we're done with the negatives, and now we need to go in order for the positives. The smallest positive number in the list is 2/10. Next one is 1/3, and then finally 4/10. So now they're in the correct order from least to greatest.